everyone. I know some of you and others I don't, but it's cool. We can get to know each other. Hang on a second. I forgot to do something. All right. So here's a little bit of bio. You can follow me at your own peril. I kind of know a little bit about a lot of things, and I'm frequently wrong. So thanks, Jade, for inviting me to be wrong in front of a lot of people. And please tell me when I'm wrong so I can be less wrong in future. Cool. So this is what we're looking at in this presentation. So we're going to try and look at a case study of a little grocery list. There's going to be some code in the beginning. Don't worry about that, because we're going to get very hand-wavy towards the end of it. So that's what we're in for. So we're going to try and do something ambitious, like trying to figure out what the essence of software development is, and going through some characteristics of models. So we're going to be very meta in that sense, and how some of this thinking has helped me to make sense of large software systems in the past. Cool. So consider a humble grocery list. It might be written on a piece of paper. You might have it on a chalkboard. You might have it on your fridge. I tend to sometimes write it on my hand, and you want to get some groceries, spam, eggs, and cheese, for example. Now, you just write it down as a list, right? You just list the items one by one down the bottom. So most languages, I'm going to be doing this in Python because it's less verbose, but a lot of this will apply to a lot of languages. And for the non-technical people, I'll talk through it so you can follow. It's fine. So you have a list, literal that we call it, and it's just saying, here's a list of strings, list of things, and it's in brackets, and that's how we would sort of represent a grocery list in Python, for example. The same thing in JavaScript, same thing. I don't think Java allows list literals. You have to make builders and crap like that, but that's the case. So once you've specified something as a list, you can do stuff with it, right? You can query it for properties. So you can figure out what the length of the list is, how many items there are in the list. There's 3 of them. And you can also reference which item in the list. So in most languages, you'd start counting from 0, and the second item counting from 0 is actually number 1, so you've got eggs there. Now, that's interesting because now our humble little grocery list doesn't have these properties offhand, right? If I ask you to give me the 52nd item on your grocery list, so for example, you work for, I don't know, in the restaurant industry, who's the big shouty chef guy in the restaurant industry? Anyway, he gives you like 500 items to go buy in Checkers or whatever, and you want to figure out what the 52nd item is. It's very difficult to do because you'd have to count 52 times. You also wouldn't know very easily how many items you have in the list. But the interesting thing is you can change that by changing the interface to your list. So by simply numbering your list, you suddenly have 2 extra properties for free. You can find out how many items there are in your list and also reference items by their numbering. So UX people, this would be up your alley. You've just changed the interface and you've got like this like extra functionality, right? And usually people think of UX like as something that you just lay on top, but it's actually much deeper than that. So in programming, you can also define your lists as objects. So we can go the object-oriented route. And over here, it's just the Python way of saying, I'm going to subclass list, and I'm going to just alias the append method to add, because when you speak to people, people don't say like, hey, could you just append this to the groceries? It's like, which world are you? Must be a programmer, like obviously. So we're just going to alias that to have a bit of more natural language. And that's the nice thing about object orientation is that you now have this sort of black box approach, and you can have your groceries defined there, and you add your items one by one. And this list is logically equivalent to your grocery list, right? Some additional things that we get from object orientation is you can now add whatever kind of interface or other APIs that you want to this black box. And say we wanted to query dairy or fruits from the object itself, then you can. And you can sort of build on that. Sort of the classical way of thinking about this is your black box with your little interface methods to access that object. So you don't really see what's inside it, but you can sort of know from the interface what you can do with it, right? But there's another way of thinking about lists. And this, you can do this in Python, but like less important than whether you can do this in language or not is the concept behind this. So suddenly you have a list, spam, eggs, and cheese, the same list that's logically equivalent to the first one, but now it's comprised of many smaller lists. So a list is now a thing that combines many other lists. Bear with me here. This is actually quite interesting because what's actually happening is there's a function being applied. So there's an A and a B, and the output is the combined list. So we're combining a list of spam to an empty list, and the output becomes a list of spam, right? But so if in a classical sense, your addition operation is the function that's being applied, and then your input parameters are those two things. So the reason why I want to do this is if you were to define it as a nested functions, which is logically actually equivalent to the first list, you can immediately see that, well, those of you who are technical, like as soon as you have nested functions, you can make an expression tree. And what's interesting about this is now, how do we get to a list of items to now a tree structure? They're still logically quite similar, or the same. They sort of mean the same thing. But now you're kind of saying, all right, my list is actually the addition of a list containing eggs and cheese that's added. The result of that is added to a list containing spam. The result of that is added to the empty list. So that's quite interesting. The more traditional model of thinking about this, you show this to a technical person, and they'll be like, of course, there's pointers, and the one memory address points to the next memory address, next points to the next memory address. But for non-technical people, it's better to think of this as a train, for example, with a train cart that is connected. And because this is like a train, it's also got a recursive aspect to this, where each cart has the actual thing that it holds, and then it's got a tail that it points to the next thing. So we're just going to take a little digression into Prolog, which is a logical language. Don't worry too much about this, but Celia's talk was very cool. I loved it a lot because he was talking a bit about Haskell and how in Haskell you just sort of like describe things and then it just happens. So Prolog is like Haskell, but like even more abstracted. And what we're saying here is that like that's an empty list, and if that's a list, then that function is also a list. So that's just saying it's not quite a function like you would see in functional programming. That's just a relation. You can replace that dot with anything, and it just says that you're just saying that thing is true. So L and the empty list is like they're connected by this dot, right? And from that, you can sort of infer other things. So more generally, if ls is a list, then L and ls is also a list. So this is just a very like fancy syntactical sugar way of saying that, of describing exactly the train. Because right at the end of it, what we're saying is that a list just has a head or tail, and the head is just the actual thing itself, the actual element in the list, and the tail is the rest of the list. It points to the head of another list. So if you look at the train analogy, a train with 4 carts is actually equivalent to a train with 1 cart connected to a train with 3 carts. The train with 3 carts is actually equivalent to a train to 1 cart connected to a train with 2 carts. And so you have this sort of recursive definition going on, right? So what is a grocery list then? Like is it line items on a piece of paper? Is it an ordered collection of strings that we're used to? Is it a black box object that you can kind of interact with? Is it an expression tree? Is it a recursive structure? Like, what's the list, right? And why is this even interesting? And I think, like, the essence of it is really when you start numbering the list, right? You gain some extra properties for free. And that's just by changing the interface. And we think of interfaces as things just, on top, like how you name a method, and that's just the interface. But it's actually more than that, because changing the interface kind of changes the structure or the topology of the underlying subject or the thing that you're working with. And different structures open up different possibilities. Is everyone still with me? Right, makes sense. Cool. That was just the grocery list. So we've now mastered the grocery list. We now know, like, all the things there is to know. A grocery list is now suddenly a tree. It's also trains and crap like that. I think we're ready to tackle the big issue here. So we're going to take a step back, and we're going to get more hand-wavy and more meta. And we're going to try and discover what the essence of software development is, because in the past 40 years of software development, no one's figured it out, so we clearly are in the right place to figure it out right now. I think everyone will be familiar with this analogy. It's a construction site, so everyone's got their builder hats on. There might be planners. You might measure some things. You might have lots of project managers and things like that doing very predictable outcomes. There's engineering approaches, and precision is very valuable in this kind of analogy, right? So I'm sure. So there's the construction analogy of software development. I think the main point about this is that the inputs in this analogy directly correspond to the outputs. So when you lay down a brick, you know that brick is going to be there and not turn into a pink elephant or something like that, right? So there's that very steady, incremental building that can occur. So if we contrast that with, let's say, the analogy of a garden, and with a garden, you're no longer laying bricks anymore, right? You're now trying to create an environment or a context in which things can grow. And your influence is somewhat indirect. So in the garden analogy, I think it's a far more organic process and things like that. But if you look at a lot of open source software, you'll find that it fits very well into this analogy, because the growth of a project kind of resembles the growth of a garden, and you might want to de-weed this part and water that part. Another analogy I quite like that's quite similar to this organic concept is the idea of your code base as an organism. So from there you can pull in ideas from biology, like environmental pressure and, let's say, natural selection, perhaps. And that's also quite interesting. But the main point is that precision is less important, and it's more about nurturing, and you kind of have indirect influence over the outputs. You're not just laying bricks anymore. That's cool. Another way to think about it is in terms of the factory. So I think a lot of our processes in almost anything that we do comes from this model, where from the Industrial Revolution, you have this sort of pipeline. And if you notice, our deployment pipelines are kind of analogous to this concept as well. But the main point here is that there's division of labor. Everyone's very specialized. You have your UX people, you have your product owners, you have your devs, your testers, et cetera, and everyone has a role to play, and everyone has kind of a playbook, like a very abstract algorithm or process that you apply when it gets to your phase, right? So the focus in that regard is productivity and throughput. So you want to get your stories out very quickly, right? And it becomes a very metrics-based analogy. So in contrast to the factory, there's also the workshop. And the workshop is what used to happen before the factories and Industrial Revolution, where people would come and learn under a master like Leonardo da Vinci, and there wasn't very much a strict division of labor. I mean, like Da Vinci himself did a whole lot of biology and physics and engineering and stuff like that. He didn't just paint the Mona Lisa. He did like a whole lot of things, and you would have apprentices that would learn under a master over the course of their lifetime. And the thing that's valued here is individual capacity or skill. So like virtuosos were very much like valued. So the workshop analogy, pretty much that. Artisanal software made from organic bespoke languages based on secret mathematical proofs by Ada Lovelace herself, passed down by traveling Hungarian monks. So you should try it with our world famous pulled pork sandwich. Why is it always pulled pork? I don't know. So if you go to like a lot of like craft beer places, they always have pulled pork sandwiches, and they like pair that stuff. Anyway, so the workshop analogy is interesting because then it becomes about teaching and learning. So and in contrast to the factory, there's a context-rich approach. So that means when you're faced with a problem, you try and understand the problem in its full complexity, and you kind of like interact with it in a very in-depth way. Versus, let's say, if you were in a factory, you'd have this list of instructions to follow if you come in if you have this sort of problem. So the individual skill is also valued above all else. So that's kind of the whole apprenticeship model. But really, you can see the contrast between the two. So which one is it, though? Like, which one is software development? Like, who's a construction worker here? Like, who's the construction worker? Anyone? Nobody? Who's the gardener? Who's the gardener? Okay, we got a few gardeners. I guess there's only two other options left. So you're either working in a factory as a factory worker, or you're, a craftsperson. Like, can I get like an indication of who thinks they're in a factory? Okay, cool. Yeah. So who's in a workshop environment? Who's the virtuosos here? Okay, great. Cool. So we have like a kind of a mix, and we don't really have a consensus on what software dev really is more like, right? So we're trying to get to the essence of what software development is. So maybe we can look at the kind of things these different places produce. And if you look at construction, it's like, very engineering type things, buildings, bridges, roads, infrastructure. If you look at gardening, it's a lot more organic and free-flowing. If you look at factories, factories and workshops pretty much produce anything and everything. And I think between these four analogies, like it's really about producing like everything that humans produce, basically. So if there's any amateur economists here, they'll pick that out very easily. But we want to try and find out what's common between all four, right? And I wonder if anyone is willing to give it a try and see. I don't think I've given you enough information, but like let's try anyway. Like if anyone, just raise your hands and shut up. Megan. Growing. Okay, cool. So there's an aspect of there is something that was there, and then there's more afterwards. Okay.
Yeah, there's some sort of physical output afterwards.
There's a thing.
There's a thing that exists after the process.
Cool. Cool. So we've got growth, and there's like a thing that happens after the process. Like, so like that gets us closer, right? So there's like things that happen, and then there's things, right? It's closer. Like, that's good. That's good because like it is really about how things are created and produced, right? So what each analogy has in common is that it's an analogy or metaphor for creation, for productive and creative things. But like, so then if we understand that, so what's the most elementary component? What's the most, like, the single atomic unit of creating things? Like, Megan? An idea. Okay, that's cool. I like that. Yeah, you have to start with an idea. And then what? There's like this one step after the idea. Planning, right. And what does planning involve, though?
Problem solving?
There's problem solving, yep. But what does problem solving involve? Oh, okay. Now we're getting like really abstract, like thinking. I think that's a bit of a stretch, right? Like, thinking is a bit of a stretch. Yeah, go ahead. Efforts, yep. Stringing a lot of components together, yep. Logic, I like that one. And people, yeah. I mean, like all of those are related. I am, and I'd like to propose maybe. They're all related, right? They're all definitely related, and you can't really separate the one from the two. But if you allow me to be a little reductive, or maybe very reductive, I'd like to propose that the atomic unit of any productive activity is the decision. So whether you're an artist or a musician that's composing a new piece or like painting, there is a decision that implicitly happens to choose the red or the blue paint. Oh, it's good to be in Pretoria. Okay, so I'm going to try and speak a little louder and hopefully not destroy everyone's ears. Tin roof. Okay, I think. Okay, I'm just going to try and continue. If you can't hear me, just like wave your hands, and we'll go ahead with it. So. Okay, do you want me to continue? Or should we just wait a minute? All right. I hope you edit this out, like in the thing. But while we're waiting, I think you can meditate on that and think about how if you are going to create something, whether it's something abstract like software, or whether it's a musical piece or a artwork, there's going to be decisions being made, right? About the color of the thing that you're working with, about what to name your class and things like that. And this illustrates it quite well in the software context. So should I name the class groceries or groceries list? And there's always some implications that come with every single decision, right? And sometimes decisions aren't just individual decisions, but shared across many different contexts and people. So, would people agree, given what we understand now, that we could say that software is the accumulation of millions of decisions? Right? In fact, you could replace software with basically any like creative thing, right? And that's pretty abstract, but like, why is this interesting and useful? Like, why are we even talking about this? The thing about understanding and thinking of this in terms of decisions means that you can now talk about it in a sort of frame of reference. So there's this idea of decision fatigue, which has been quite popular in like recent times with pop culture. And this is the idea that you have when you wake up in the morning, a reserve of energy to make decisions. And that's why some designers or whatever like are using this idea to live a minimalist life, for example. So they only have like one pair of shoes, and so they don't have to decide between different things, and so that they can keep the decision reserves for more important things. So in fact, I don't know if you guys do managers and stuff like that. In fact, I would say like the manager's primary job is to make sure your technical people have the right information in the right sort of detail in order to not suffer from decision fatigue and things like that. So once we talk about decisions, we can think about trade-offs, because in essence, every single decision is just a binary thing, right? You either do you either do it or you don't. That's essentially it. And the way to evaluate why you want to do it or not is to find the trade-offs. So whether you're choosing a design in your code, or whether you're trying to get the team to decide on which feature or how to implement a feature, you'd have to bubble up these decisions and figure out what the trade-offs are. And thinking of them in a very explicit manner allows you to do these things. Tying into that, like decisions treated as first-class citizens can be deferred, they can be delegated, they can be discussed. So one of the most important things that I discovered and learned and was like most useful to me was this idea of using the last responsible moment. So it comes naturally to me because I'm a chronic procrastinator. So you can just like leave things till the very last moment, but it's actually very helpful, it turns out, because when you have to decide on like a tech stack, should we use this tool or that tool and things like that, you can stop and ask yourself, all right, we have a decision point. Is it worth it deciding it now, or can I defer this to a later point? And then you can just take that decision and just throw it over the wall to the next iteration or next sprint or whatever. I kind of use this all the time in my personal life as well, like because I like procrastinating, but it is actually very useful. And it helps you to avoid decision fatigue. The delegation is interesting because now when everyone's shouting about like, you don't know what you're like talking about. If you like find the decision that you're trying to decide on, then you can put it in an email and you can send it to the right person to say, hey, here's a decision. We don't have to deal with it now. And obviously you can discuss it if it's a first-class citizen. So there's the other concept that distributed decisions have a cost. And I'm going to show you in the next few slides. And I apologize. I will need to find some graphic designer friends to help me write this stuff out. But anyway, so imagine like a decision would have this kind of feedback loop. You want to observe, you decide, and you act. In fact, in the military, there's the OODA loop, which is like observe, orientate, decide, and act. And they kind of use that as well. But in essence, that's what it's about. And like it's very easy to do if all of that happens in one head, right? And it becomes a very fluid thing. You get flow, right? It's like you don't have these like discrete steps. It's just continuously happening, right? If it's in one person. But you add two people to the mix, and you have this sort of two-way communication. And now suddenly, what's in my head needs to now be in someone else's head. And I'm kind of hoping that it's in like the right level of detail or fidelity for them to kind of understand, and we can now collaboratively come to a decision. Then there's the third order problem, which is having multiple teams collaborate and come up with these decisions. And this ties in very well to the concept of Conway's law and microservices and all of that. And a lot of the enterprises today are trying to follow the microservices approach because you want to kind of decouple the teams and avoid that hop, right? So a single team in a microservices architecture kind of organization should be able to decide many things and have that decision go all the way to production without interacting really with the rest of the organization. The way you do this is by normal practices like your API versioning and things like that. But very rarely is the case that this happens in organizations because of Conway's law, where they've kind of now specified a technical architecture. And we're like, we're going microservices. We're just going to split things up, right? Just like if you go agile, you're going to just take a project and chop it up, and then now you're agile. So it's incremental. You're just delivering stuff, right? But like how you chop it up matters, right? So a lot of organizations struggle with this idea because they're kind of going from the top down, and they're like, okay, we're just going to take our big monolithic system and just chop it up, and then you're this team and that team and that team, without thinking of like, can this team actually have this direct feedback from production and its users independent of everyone else? And that's usually not the case. Anyway, this is usually like a problem that's way bigger than us working in the teams, but it's helpful to be aware of it. So, congratulations, everyone. We've gotten to the essence of software development. Like, we can totally go and, point out, make fun of all the previous computer scientists before we tried to do this. But let's try and go a bit more meta, right? So that was pretty meta. But like, let's look at models themselves and like kind of characteristics of models that we can perhaps maybe bubble up and investigate. So models, I guess, have a medium as well. Like, so they can be in natural language. Like I'm trying to explain the grocery list in natural language, perhaps. You can use mathematics and logic, graphs and diagrams, code, sticky notes, paintings, sculptures. Anything can be a model that you can point to, right? But another interesting thing is that they can have a structure. The way I like to think about this is using this kind of approach where you have levels or intensities, like I'm speaking into the mic and this is much louder and softer. So there's the levels as a model approach. You can have models as layers, right? So this is very common in network architecture. You want to like have this layered approach. There's also the relational or network based model. There's procedural. I do this, and then do that, and then that, and then that, and then there's boundaries and maps. This is by no means a comprehensive list. I just sort of mostly made this up. So if you guys find other things and other resources, please like tell me afterwards. So models themselves, there's other things you can do with them. You can use this idea of precision to tweak your models. So once you've established that, okay, I want to use this network model, I think this problem really like resounds in like this network aspect, or this problem is really about intensity, so I'm going to use levels, or it's about layers. You can use precision to tweak how that model looks or how that model works for you. And I like to think of it in terms of like the precision slider. So you can go down into having more detail, but its potential for noise increases. So you might get overwhelmed if you're like too down low in the detail. You could also have less detail, but then it could be so abstract that it's not useful at all. So using the precision slider, you can figure out how detailed you want to be with your models. Okay, that's way too meta. So let's try and see how we can use specific models to make sense of a large software system. And I'm going to go a bit technical here because one of the issues with like as programmers, we start off working with text in your IDE or your text editor, and then you press play or compile or whatever. And you don't really know what happens afterwards. This is fine if you're working on like a desktop application, but like most systems, there's a whole lot of stuff that happens between typing your code and like someone interacting with your code. And this is something I had to learn the hard way, being thrown into like really complicated projects that like you have no idea what the hell's going on. And you need to have a mental model to make sense of this. And initially, like a very good way of thinking about it is your write and run. So if you went to varsity, you probably use Scintilla. For some reason, they use Scintilla text editor and stuff like that. Yeah, remember that? And you just like write your code and then you run it. And okay, so that's a good model in itself because there's like write time and there's run time. And then you can think about the kinds of decisions that can be made in write time and run time, whether it's with your individual project, your small project, or on a larger scale. So for example, on write time, you might want to choose whether you're using a monorepo or a multi-repo. So monorepo is like you have all of your services and all of the code in one repository. Multi-repo is that each one split out separately. So Google uses a monorepo, multi-repo. Non-technical people, don't worry about it. It's just the way you organize your folders. Like that's basically it. And then in runtime, you can think about the kinds of decisions that would happen in runtime. So do you want to make this a synchronous call or an async MQ call? So like HTTP versus MQ, essentially. But then remember the precision slider. And now we can get a bit more precise, because write time and runtime are just very massive, high-level things. And you realize that, wait, there's a build time that occurs in between the write time and runtime. And that's where your dependency management can happen. It's your NPM packages, your DLL linking, your Artifactory sort of pulling and things like that. And you can think of the decisions that can occur there. Build time is not just build time, right? There's tests and integration that occurs. So like in integration, you can choose trunk-based or feature branching, and your testing probably, if you were to get more precise with the testing, you'd probably split that up even further to unit testing, component testing, integration testing, smoke test, all the tests there. But I think we're just going to go straight to deployment there. And then, as you can see, like just starting with like a simple structure, you can use precision to figure out if there's something you're missing in between the boxes and lines. So boxes and lines are a great way of like helping you think about any kind of problem. And you can look at like, is this box actually two boxes, or is there another box that needs to be in between this line, right? And I just added release there in things, because like, who here works with feature flagging and, cool. Oh, yeah, that's cool. Okay. But yeah, so like this is the golden like standard, right? Where you decouple your deployments from your releases. So like you can deploy every 10 minutes or whatever, it doesn't matter. Whenever someone pushes code, it goes through automatically and deploys. And you put the release button on the CEO's desk and he releases whenever he wants, right? That's the gold standard, but like in practice, it never really works out that way. But so yeah, that's just another way of saying like going from very low precision to a much higher precision. And that's just the full thing. So that was a very like time-based model. So we're talking about write time, runtime, like when you would do things. So what if we tweak the model a little bit and think about how the software looks from a layered perspective? And I think this is pretty self-explanatory, but the idea here is if we think about things in layers, so all of this probably happens in runtime from the previous model, but now we kind of changed it up a little bit and we're looking at infrastructure. So if we take the example of Twitter, your data at the top will be your tweets. Your infrastructure is the actual data center and the equipment that Twitter runs on. And configuration is your IP addresses, your credentials, the way your databases are connected or replicate and things like that. And then your code is the thing that you actually deploy and you change and you evolve. This has actually helped me before in terms of explaining to clients why you don't need to actually redeploy your code in order to change a configuration or some data, right? So I was once working on a project where everyone just assumed that this particular change required a brand new version of the entire system to be deployed. When we dug a little deeper, we realized that we could just build that as a feature on the actual system. So what they were actually doing is they were deploying every time a tweet was actually required, right? So their model, their mental model of their own system was a bit wrong. They thought that like they needed to hard code and redeploy everything just to change what essentially should be data. And the interesting thing about the layered approach here is that you can look at time as well in terms of periods, right? So things that change least often would be at the bottom, and things that change more often would be at the top. So those were two models that I used quite successfully before, but there's caveats to that, but let's go to conclude. Abstractions of the tools of knowledge work. Would you agree with that? And that means that mental models are quite useful, right? And you can think of mental models as the toolboxes from which you draw a set of tools. So if you adopt a mental model, it gives you different things to a different mental model, right? And you can sort of look at the same subject or problem in different ways. Good news, everybody. There's no such thing as truth. So the point of this is that all your models are wrong. Truth is out there somewhere. We probably won't find it, but choose the model that will be useful to you at that time. And don't get too hung up on being no, you're wrong, or the thing that I have in my head is more correct than yours. It's just more correct to do, or it's just more useful to do certain things. So you have to be flexible in that regard. And to conclude, the shape of a problem really so the shape of a problem really depends on the abstraction you choose. So, yeah. Questions?
Questions, of course. Who else?
Mag ek maar. So, talking about models and reaching the point where you have a layered approach, monolithic, and you can look at the model in different ways. But today, I feel it's hard to pick just one. You kind of have to, for a specific problem, combine models. But your view or your opinion on the challenge of then, do you still, you need more than one model to fit this problem space, so you have the layered components and you have, microservice components or whatever. Do you still need to try and think of them separately, or does it kind of, because then if you don't keep the models separate, you need both, for example, but if you don't keep them separate, you can easily get bogged down, and it can become a mess. But what would you say is the approach to that, just from a thinking point of view? And sorry for the super vague question.
So, yeah, I get it. So just to reiterate, you were saying it's difficult to pick just one model, right? And I think the idea that all models are wrong but some are useful is helpful in that regard when you think about what is the decision or the goal that you're trying to achieve. And at some point, you're going to have to choose, right? And there will be trade-offs. And so when I used to play games, I would have 500 save games in a tree structure because I didn't like choosing. And then it turned out that I'd never finished Fallout because but at some point you have to say, this is the threshold with which I'm comfortable to adopt this decision. And trust me, it's difficult for me as well. The other point is that the models aren't static. I may have explained things in very concrete terms in some regards, like this. So this that I've drawn here isn't necessarily the model that everyone should have in their heads, right? This is just for me to communicate to you certain aspects of it. And the thing about models is that they're never static. They just by interacting with them and just by thinking about them, you kind of take them with you and they evolve with you. And you just have to be aware that a model isn't a very precise thing that you just choose, right? It's something that needs to have a conversation with your domain or the problem that you're having.
Cool. Any more questions? Megan.
Oh.
Who else always has a question? I want more of a question.
More questions?
Okay, I will say this. No one's going to ask. So, when did this all start solidifying for you as oh wait, cool, this is how we should think about models. Models help us. Was it something you came on early on? Was it something since you've left ThoughtWorks and gone on your explorative journey of code?
So this, I think, has always been kind of implicit in the way that I think and approach problems. So just from my personal experience, I struggle keeping a lot of things in my head, actually. And the way to deal with that is to, in a very structured approach, take one piece at a time and make that. But the problem was it wasn't explicit in my head. And I would run into the same kind of problems in a lot of projects where you'd have to try and explain to other people and you'd have to come into consensus. And this kept happening. And it was actually, I had a few notes, but it only became explicit once I sat down and actually said, okay, I have to write a talk now about this, but I had to collate all my notes and be like, pull on this thread and very inductively go stepwise and like come up with like a proof, basically, of how I approach things. Because previously I would have just, relied on personality to be like, yeah, that's just my personality of being technical or whatever. But understanding that there's a process behind that, like whether it's implicit or not, then you just pull that out. I think that was helpful. But it's probably not what you were asking. You were asking when.
No, I'm not even. I think it might have been that, because what it sounds like, it almost takes like quite a bit of self-reflection. And it's always forcing yourself to do something. So for me, it would be like presenting something or writing a blog post. And it's the first time you sit down and think, how do I do things? And how could I do it better? And how can I explain the way I do things? And as you say, remove it from your personality. So I tend to think that's kind of important. And I think us as software developers, and maybe anyone living in this world, are always too busy trying to get things done that we never take that time to be like, am I, self-reflect and look, okay, what are my working behaviors? How am I doing this? Like, looking at it, analyzing it. And I think the next talk might even touch on it in a certain way.
So none of this happens during work hours. Yeah. This is all like when you're lying awake in bed.
Yeah.
And you're in the shower or something. Yeah. So I think it takes time.
Cool. Any more questions?
So just one question. One thing that I know is like models, of course, help you be a better developer to like pick up problems, know where to jump in and stuff. But if you had to join a project that's already been launched, that's quite massive. How would you go about forming your models when you come, of course, completely new to this project? What do you find works best? Do you find like going through the code itself, or do you find just maybe stepping back and like asking people questions?
Sure, that's a tough one. Because previously, like my experience, it's just been random. It's always been loads of information thrown at me. And I think it happens, it's happening right now actually. I've just joined a new project, and the way to go about this is you have to at some point say this is noise and this is signal. And you have to kind of file the noise away for a later time and come up with a way to say, all right, what is more important? Like you kind of rank that. Let's say, for example, like you're working on something that has a lot of asynchronous queues, for example, and there's also this aspect of a large web application features, and you know nothing about either of them. You have to make the choice that says, all right, I think, or I have this like feeling that this part of the system is more important. So therefore, everything else, I'm going to just add to noise. And it's very difficult to do if you're in like a corporate environment, because people don't know what they're talking about, or people assume that you understand what their acronyms and TLAs mean, 3-letter acronyms. And you kind of just like suddenly in a meeting and no one knows what's going on. And it's very difficult to not get overwhelmed. And the way in which I approach this is the things that are important will bubble up to you as you need them, and you have to trust in that, and you can't be omniscient either. So you kind of lean on your BAs, if you have BAs, and product managers and other people to say like, hey, can you help me with this thing? Which one should I prioritize? So you kind of put it to them, like make the decision for me, based on whatever thing that you think is important. But you need to help me so I can do my job. Yeah.
Is that all you could? Do you want to ask one? Anyone else? Hands up high, because I'm mostly blind. Okay, cool. Well, thank you very much, Sett. Round of applause.